Another concept we're going to now talk about is x and y intercepts. So I'm going to first draw your attention down here to the definition, and then I'm going to come back and look at the graph. So the first thing I notice is that a y-intercept is a point where a graph crosses the y-axis. So I'm going to go ahead and pause this video and go ahead and add the names of each of the points of each of my y-intercepts on these four graphs. Now if I look at each of these points and I ask myself, what do all of my y-intercepts have in common? Well, I can see that all of them, because I named the x value first, have an x value of 0. So if I want to find a y-intercept, I am being told in an implicit manner that x equals 0. So I'm going to go ahead and plug 0 in for x, then solve for y. If I go ahead and pause my recording again and add in the names of all my x-intercepts, the x-intercepts being the point where the graph crosses the x-axis, we'll then see how we can find an x-intercept. So I'm going to go ahead and do that. Now looking exclusively at my x-intercepts, I have 3 equations that cross the x-axis. Notice the red one does not. Now I see that they also all have a 0 specifically in the y-axis. So when I'm asked to solve for an x-intercept, again, I'm being implicitly told that y equals 0. So I'm going to go ahead and plug 0 in for y and solve for x. And I can't find my stylus, so I'm sorry if that's hard to read. So hopefully you're listening to this video as you should be. So it does say plug 0 in for y and solve for x. So make sure you've got that written down. And now we're going to actually go ahead and look at finding x and y intercepts. I do have 2 examples. The first one we're going to find the x and y intercepts and then graph the equation. And then on the second one we're only going to find the x and y intercepts. So I'm going to go ahead and say I'm going to find the x-intercept. Or I guess I can find the y one first. It doesn't matter the order you find it in. Well, I know that if I'm finding a y-intercept, according to what we looked at just a moment ago, that means x equals 0. So I'm going to plug that 0 in for x. Everything else will stay the same. So I'm going to have 2. Remember, as we've talked about before, I plug things in with parentheses. Times 0 plus 12 equals 3y. Well, 2 times 0 is 0, so that's gone. So I have positive 12 equals 3y. Dividing by 3, I get y equals 4. So as a point, when x is 0, y is 4. So either way, these both can symbolize meaning my y-intercept, as long as I remember the context of the question and that this is implying the y point as opposed to the equation. So it is actually better to write it in point form. Now I'm going to go ahead and find my x-intercept. Remember, with an x-intercept, I want to go ahead and say y equals 0. So again, everything else gets copied down, so 2x plus 12 equals 3. Again, I'm going to plug in with parentheses, times 0. So simplifying, I get 2x plus 12. Oftentimes when something equals 0, I don't write it, but if there's nothing there, I have to use that 0 as a placeholder. Now I can go ahead and solve for x by getting rid of anything not attached to the variable, leaving me with 2x equals negative 12. Dividing by 2, I get x equals negative 6, so written as a point, x is negative 6 when y is 0. So now if I want to graph this equation, remember one of the ways we learned how to graph, one of the techniques was to change it to y equals mx plus b form. Well, when it's in y equals mx plus b form, remember the strategy we use. We plot the y-intercept and then we use slope to plot a second point. And then I just connect those 2 points with a line. Well, don't I have 2 points here? So what if I just plotted those 2 points and connected them with a line? Well, then I would plot the y-intercept 0, 4. That should be a point. And then I would also plot the x-intercept negative 6, 0, so back 6. And then I can go ahead and connect these with a straight line. So just another technique for graphing equations. We're going to look now at example 2. I don't ask you to graph example 2, and the reason is because if I'm not going to get very nice numbers. It's going to be difficult to graph on this one with the x and y intercepts. This would be a particular situation where y equals mx plus b would be much more helpful in graphing than x and y intercepts. So just going through and finding the x and y intercepts, I'll first start by finding my y-intercept. And I know with a y-intercept that x equals 0. So 3y minus 4, instead of x, I'm going to plug in a 0 in parentheses, equals 9. So minus 4 times 0 would be 0, so I'm just going to have 3y equals 9. Dividing by 3, I get y equals 3, writing it as a point. When x is 0, y is 3. And then finding my x-intercept. I know that in order to find an x-intercept, I let y equal 0. So I'm going to have 3 times 0 minus 4x equals 9. So 3, 0 becomes nothing, so I do not have to write that. Remember, sign belongs to the number, so the minus drops down with the 4. I want to get rid of the minus 4, so I'm going to divide both sides by minus 4. And I get x equals, it is more common to put the negative on top, so instead of saying 9 over negative 4, I'm going to say negative 9/4. So again, writing it as a point, x is negative 9/4 when y was 0. And there are my x and y intercepts. So big thing is to remember how to find your x and y intercepts. If you get nice whole numbers for your x and y intercepts, they can be helpful in graphing. However, if you're getting y and x or y intercepts that involve fractions, it's extremely difficult to graph that with accuracy. So it's better in that situation to change to y equals mx plus b form if asked to graph, which in this case I wasn't. Bring these notes with you to class. Let me know if you have any questions on them. Otherwise, they will be a great tool for you to use when doing your practice.